All right, hello Algebra 1, or Algebra, I'm sorry, Geometry Honors. This is lesson 4.5, Prove Triangles Congruent by Angle, Side, Angle, and Angle, Angle, Side. And what I'd like for you to do is pause the video and go ahead and jot down Postulate 21 and Theorem 4.6. So go ahead and pause it. Write all these down and then unpause it and we will continue. All right, so far we've learned side, side, side could be used to prove triangles are congruent, side, angle, side, hypotenuse, leg, and now we're looking at angle, side, angle, and angle, angle, side. And an example of that would be for angle, side, angle. It's important to realize that, yeah, you need to know two pairs of angles are congruent, but you also need to know a pair of sides is congruent, but the placement of it is important. To be angle, side, angle, the side needs to be included between the two angles. It needs to be in between. And if you have that, you can say that triangle ABC is congruent to triangle DEF. So that's for angle, side, angle. And that one's kind of intuitive because, and the reason it's postulate is it is intuitive. If you have a pair of sides that you know are the same, and then you know that those angles coming off of that side are the same, that causes these to meet at the exact same kind of location. So yeah, I think it kind of makes sense. I don't think we really have to prove that too much. Now, angle, angle, side is a little more complicated, a little less intuitive, and there is a proof for angle, angle, side that you can do or read on. But angle, angle, side, again, the kind of order matters here. In the definition, it says that it's two angles that you know and the non-included side. It's not the side in between. So if you have these two angles that you know, to be angle, angle, side, it could be either here or here. It's not going to be in the middle because that would be angle, side, angle. So we've got triangle GOT congruent to triangle HAM by angle, angle, side. All right, so let's move on to example 1 here. It says, can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem that you would use. I'd also like to write a congruent statement just to get practice with that. I assume they're talking about the triangles that we know the most about, so let's focus on this triangle and this triangle. Do we have enough information? We sure do. It's angle, side, angle. Angle, side, angle. The side we know is the included side between the angles. And let's see, if I name it triangle EAD in my congruent statement, I've got to name the other triangle, so EAD, EBC, to get it to match. Oops, there we go. All right, let's move on to B. Looking at this triangle and this triangle, is there enough information to tell that the triangles are congruent? Yes, in fact, there is. And in this one, we've got angle, angle, side. So I'm going to name it triangle ACB. And if I name it triangle ACB, I got to name it, say, ACB. So, yeah, triangle ECD to get it to match up for my congruent statement. And then finally, on example C, we're looking at the two triangles there. We know all the angles are 60, which is pretty cool. But we don't know anything about the sides. And what happens is yes, these are equal angular, and we have learned, I believe, that if it's equal angular, it's also going to have to be equilateral. But just because you have two equilateral triangles doesn't mean they're congruent. They have the same shape, sure, but it's not a guarantee that they're the same size. So yeah, we've got angle, angle, angle here. That's not enough information to prove that they're congruent. This triangle could be a little smaller, a little shrunken, could be a little bigger, okay? Not enough information to say that they are congruent. Okay, next we're going to look at a new way to prove things. It's not actually new, it's just a little more descriptive. A flow proof uses arrows to show the flow of a logical argument. Each reason is written below the statement it justifies. And with flow proofs, you can either kind of start at the top or start on the left and move over. But what's kind of interesting is you use boxes and arrows in this proof. It's not a two-column proof, even though it has the same elements. So you start off with your given, and I like to just list out all my given. Some people like to save it for appropriate times, and that's probably a better way to do it, or a more thoughtful way to do it. But I just kind of make sure to document everything at the beginning. So instead of having a statements and reasons column, we just start writing everything out and putting it into boxes. Now, where did I get that information from? That was given. So instead of having a reasons column, you put your reasons underneath. Now, whenever we're doing a proof, I like to mark any congruence relationships on my picture to help us out. Oh, I also got to tell you, these are a little presumptive right there. I actually don't want those in there right now. So pretend like those right angle marks don't exist, because we aren't given that information, okay? What we are given is that we have some perpendicular relationships, and we'll get to those right angles in a second, but not yet. All right, so let's look at AC and DF. Those are congruent. Let's mark those with some tick marks. We also know angle C is congruent to angle F, so arc marks. But then, yeah, so let's kind of make a plan here. Our plan is, or we need to prove that the triangles are congruent. And looking at what we have, we do know some perpendicular relationships, so we are going to be able to get to that right angle stuff, but we're actually going to have to make that part of our proof. But after we get there, I believe we've learned that you can, if they're right angles, we know that they're going to be the same. So what relationship could we use to prove these triangles are congruent? That's right, we should be able to do angle, angle, side to get these triangles congruent. We already know the sides, we already know the angles, so we're going to have to use these perpendicular statements to work it out a little bit to show that these are congruent. So first things first is I'm going to say that angle B and angle E are right angles. Now, the reason I know that is because of the definition of perpendicular. And we got that information from this right here. So there's the flow part of our proof. They told us two segments are perpendicular. That means the angle that they form is a right angle. Definition of perpendicular. Now, we can say, if they're both right angles, we can go ahead and say that angle B is congruent to angle E. And the reason we know that is because of the right angles congruency theorem. If you just say right angles congruent, I'll be certainly satisfied with that. Now, how did we know we had right angles? From up above there. So that's how our proof is flowing. At this point, we know a set of angles, set of sides congruent. We're ready to go ahead and say that triangle ABC is congruent to triangle DEF. And we know that because of the angle, side congruence theorem. If you just say angle, side, you're good. Now, because we used angle, side, we need to have gotten that information. We should have showed that the angles, two sets of angles are congruent, one set of sides are congruent. And so we're going to draw arrows from that information to our conclusion. And there is a flow proof. All right, I'm going to pause right there, and I'll do another video here in a second.